So for 4.2, we're going to talk about something called least squares regression, and this is going to be very similar to what you learned in algebra for linear regression equations. Okay, and this is in a PDF format now, only because there's so many things that we're missing in the PowerPoint here. So we'll try using Notability again. So during this video, we're going to talk about the first of the two objectives here. So we're going to find the least squares regression line and use that line to make predictions. Again, least squares regression is the same exact thing as a linear regression. We'll get more into why it's called least squares regression in a few minutes. And then tomorrow when I see you in class, we'll talk about how to interpret the slope and y-intercept of the least squares regression line. Okay, so before we get into a regression line, we're just going to talk about a regular old line in terms of how you did in the algebra. So using the following sample data, find a linear equation that relates x, the explanatory variable, and y, the response variable, by selecting 2 points and finding the equation containing those points. So just FYI, if you were to plot all those points, they are not going to lie on a perfect straight line. Okay, so it is a scatter plot here. So again, for this example, the 2 points that I'm going to fixate on are 2 and 5, 7, and then 6 and 1, 9. So again, hopefully from algebra, you remember that anytime that you're writing the equation of the line, the first thing that you always need to find is the slope of the line. And again, we'll have to remember the slope formula, which is y1 minus y2 over x1 minus x2. And again, how am I getting x1, y1? From your ordered pairs. So we'll have x1, y1, x2, y2. So now all I'll do is plug that in. y1 is 5.7 minus y2 is 1.9. And on the bottom, x1 is 2 minus from the formula, and x2 is 6. And again, when you subtract on the top and then on the bottom and then divide, you should get an answer of negative 0.95. Again, when you're putting that in the calculator, if you're doing it all at once, just make sure that you put the top and the bottom in a set of parentheses, or it is going to give you a wrong answer. So if you just did that in the calculator at the same time that I did and you got a different answer, it's probably because you didn't put the top and the bottom in a set of parentheses. Hey, again, you can always do the top first, so 5.7 minus 1.9, hit enter, and then divide that by your -4 so you don't make a mistake. All right, so now we need to write the equation of the line. So again, from last year, hopefully, or last year, or whenever you had algebra, there were 2 forms of a line that you can have. You can have the slope-intercept form of the line, which is y equals mx plus b. Again, it has your slope and the intercept. Or we can have the point slope form, which is y minus y1 equals m times x minus x1. So for this example, or really any example, it's always easiest to start with that point slope form, and then eventually we'll transform it into y equals mx plus b form. So if I have y minus y1 equals m times x minus x1. Again, when you're writing the equation of the line, you want regular old y, regular old x, and that regular old y, regular old x in the equation at all times. I was a step ahead of myself. What you are replacing is the y1, the m, and the x1. Okay, again, so I'm going to bring down the y. I'm going to have a minus from the formula. And now where is y1, x1 coming from? It's going to come from one of the 2 points I chose. Again, it has to be from one of the 2 points I chose since this was a scatter diagram. Otherwise, it wouldn't matter. So since I already have this ordered pair labeled as x1, y1, I'm going to use that one and ignore the other one. So y1 is going to be 5.7 equals negative 0.95 times x minus 2. Okay, and that is the equation of the line, but now we're going to transform that into y equals mx plus b form. So I'm going to distribute that negative 9.5 through the parentheses. So I'm going to have y minus 5.7 equals negative 0.95 x plus 1.9. Last thing I'll do is add 5.7 to both sides. That will leave me with my y on the left, and on the right I'm going to have negative 0.95 plus 7.6. Oh, I forgot my x there. Okay, so y equals negative 0.95x plus 7.6. Okay, and then if we were on the next slide, what we're going to do is we're going to take a look at what this would look like if you drew a scatter plot of it. So there is the scatter plot on the left-hand side, and this line in blue here is the actual line of that equation from here that we had just found. Hey, again, to get that line on the graph, you can put that into y equals in the graphing calculator and then go into your table and pick off any 2 points and estimate where they are and then connect the dots and you'd have your line there. Okay, and then for part C, we want to use this equation to predict what would happen if x equals 3. So literally all you're doing here is taking out your x and replacing it with 3. So we're going to have y equals negative 0.95 times 3 plus 7.6. And when you do that, you should get an answer of 4.75. Okay. So if you go back and look at the table of values, when we had up here, when x was 3, your observed value was 5.2. And when we predicted it using this line that we just found over here, we got an answer of 4.75. So you can see it's close, but it's not exact. So we have an observed value and we have a predicted value. So now let's talk about this least squares regression line. Okay, and again, we're going to use that line to make predictions. Okay, so I was just talking about the observed value and the predicted value, and here's the reason why. The difference between the observed value of y and the predicted value of y is the error, or again from algebra, hopefully you learned the word residual. Okay, so using the line from the last example and the predicted value of 3, the residual is going to equal the observed value of y minus the predicted value of y. So again, I just showed you that x equals 3 by coming off the chart. Coming off the chart, that's again your observed. That's the 5.2 that they have right here. And that 4.75 is what we just found using the line that we had found, the equation of the line that we had found. So when you subtract there, you get an answer of 0.45. And if you look at the picture below, if you go over to where x equals 3 and then go up, again, that red dot is what we had found by using the actual equation with x equals 3, the 4.75. And then again, this was the actual point. Okay, so you can see again, the difference there is going to be 0.45. If you ever forget the order of observed y minus predicted y, it's alphabetical also, just so you know, so you can keep the order straight there, because it does make a difference. Okay, so what's going to happen now? The least squares regression criterion. Okay, so this is why we're talking about those residuals in the last one and why we have the word least squares instead of just a linear regression. The least squares regression line is the line that minimizes the sum of the squared errors, okay, or the residuals. Okay, so those residuals, again, we're going to minimize the sum of the residuals squared. That's what a least squares regression line does. Okay, and again, it's the same exact thing as a linear regression line, but now you know why it's called least squares, because that line is minimizing the sum of the residuals squared. Okay, in other words, it's giving you the best estimate of that data. Okay, this line minimizes the sum of the squared vertical distance between the observed values of y and those predicted by the line y with a hat. The y with a hat is not printing out well in the PDF, so that's what this is, the y with a hat. Okay, and again, that's minimize the sum of the residuals squared. Okay, so the least squares regression line. So again, you can find this information directly in the calculator, but again, we're going to find some of the information by hand first before we use the calculator completely here. Okay, so this again should say y with a hat. Okay, so the equation of a linear regression line is given by y with a hat equals b sub 1 times x plus b sub 0. And again, this is directly related to your line y equals mx plus b. We just got fancy with the y with the hat, we got fancy with the b sub 1, and we got fancy with the b sub 0. Okay, again, ultimately, they're very similar. Okay, so b sub 1. B sub 1 is the coefficient of x. The coefficient of x and y equals mx plus b is m, which represents the slope. And look at that. B sub 1 is the slope of the least squares regression line. So again, we're going to find that for the most part by hand. So how are we going to do that? B sub 1 is going to equal r times s sub y divided by s sub x. So what are those r's and s's and sub y's all about? R is the correlation coefficient, which we have found before. S sub y is going to be the sample standard deviation of your y values, and S sub x is going to be the sample standard deviation of your x values. Okay, now, technically, from sections that we've done in the past, we can find all of that information by hand and then find B sub 1, but we'll be here till New Year's Day if we do that. So we're going to cheat and we're going to get this information out of the calculator to figure out B sub 1 by hand. Okay, and then we're going to find B sub 0 as well. Okay, and again, B sub 0 is directly related to the y-intercept and y equals mx plus b. And again, you can see B sub 0 is the y-intercept of the least squares regression line. And how are we going to do that? B sub 0 equals y with a bar minus b sub 1 times x with a bar. What do y with a bar and x with the bar stand for? Again, that goes back to something that we learned earlier. Those are the means. So it's the mean value of y minus b sub 1 times the mean value of x. And again, that b sub 1 we're going to get by figuring out what we just talked about above, r times s sub y divided by s sub x. Okay, and this is pretty much just everything that I just said out loud is written now on this slide. So the least squares regression line, x with a bar is the sample mean, s sub x is the sample standard deviation of the explanatory variable x, y with a bar is the sample mean, and s sub y is the sample standard deviation of the response variable y. So here's the problem that we're going to look at, and then we're going to answer these 4 questions. So we're going to find the least squares regression line. And again, we're going to find the slope and the y-intercept for the first time around by hand. I'll also show you how to pull it directly out of the calculator eventually. Okay, then we're going to predict the drilling time if drilling starts at 130 feet. And is the observed drilling time at 130 feet above or below average? And then we're going to draw the least squares regression line on the scatter diagram of the data. Okay, so the first thing that we're going to have to do is we're going to have to put all of this information into the calculator. And I'm going to do one thing before we get into that calculator. Again, that's y with a hat. Okay, so again, in order to find this line, we're going to have to find B sub 1 and B sub 0. So I'm going to have to go into the calculator and I'm going to have to find a bunch of different information here. Okay, we're going to end up having to do 3 different things. Okay, I'm going to put all this information into my list in the calculator, into L1 and L2. Okay, so the 4 pieces of information that I need, and again, we're going to have to do 3 separate things on the calculator, because when I'm talking about standard deviation and mean, your calculator can only look at one list of data at a time. So the first thing I'm going to do is I'm going to go into the calculator where we're going to put all this information in, and then we're going to talk about our x's first. So the first thing that we'll find is x with a bar, and since that information will be in the calculator at that time, we're going to find our sample standard deviation of x. Once we find that, we'll go back in and then we're going to do the same thing. We're going to have the calculator calculate the information for L2 to find our y with a bar and our sample standard deviation for y. And then the last thing that we'll do is we'll go back in and we'll have the calculator look at the 2 lists of data at the same time in order to find the correlation coefficient. So inside the calculator, again, to get that information into your list, you're going to hit Stat and then Enter. We want to edit that. And again, you can see I've entered my data in here already. So straight down L1 was your X values, straight down L2 was your Y values. So again, now I'm going to go back into Stat and I'm going to go over to Calculate. And again, we'll talk about the statistics part first. So I need option number 1. And I want my calculator to look in L1, which it is right now. Remember, if yours doesn't, you can just clear it out and hit second and then the number 1 to get L1 in there. Okay, and again, I'll hit enter. And then what comes up, again, is your list of data. Again, right now, there's only two things that I care about right now, the X with the bar and the S sub X. So X with the bar, the mean is 126.25, and your sample standard deviation is the one that has the 52.2287364302. So we'll take a second, we'll go back in, and we will write down that information so we have it handy. So I'm going to have 126.25, and my sample standard deviation for X is going to be 52.2287343. And yes, I really did just write all that information out. Don't round. Okay, don't round until the very, very end. I know a lot of times you think if you round at least 3 or 4 places out from the decimal, it shouldn't affect your data value, but it will. Okay, so do not round until the very, very last step. Change the color of my pen. So now we're going to go back into that calculator, and we're going to have the calculator look at the Y side. We're going to have it look at L2. So your information is already into the list. So we can go directly into stat and then over to calculate. And again, we want one variable statistics, but this time again, I want it to look in L2. So if you go and do L2 again on your calculator, you're not going to do what I just did. You're going to hit clear it out and then hit second and then the number 2 to get that L2 in there. And then again, once I hit enter, my information will come up, and my X with a bar is 6.9858333333. And then again, my S sub X. Again, your calculator doesn't know that you're dealing with Y right now. It's never going to change this list to a Y value, but we have to know it's our Y values. So the sample standard deviation here is 0.7807741884. So again, we'll go back in, we'll write that information down. So again, our Y with the bar was 6.98583333. Okay, and my S sub Y is going to be 0.7807741884. Okay, so the only other piece of information that I'm missing right now is my R value. So now I'm going to go back in and find my R value. How am I going to do that? Again, your information is already in L1 and L2. Your R value is in with the linear regression. So when we hit stat, we're going to go over to calculate, and we want option number 4. Okay, and again, it's looking in L1 for your X's, L2s for your Y's. And if you just hit enter, again, you can see on the right-hand side, again, I'm interested in R, not R squared. So all we need is that R. So again, I'll bring that into the thing here. So R is 0.77228215305. Okay, so again, the first thing that we're going to do is we're going to find B sub 1. Okay, now I'm going to abbreviate here only so that I have room and it's not all over the place. But again, please make sure you are not abbreviating you're not rounding until the very, very end. So B sub 1 is R, which is 0.7728, I'll say, times. On the top, I need S sub Y. That'll be 0.7808. And on the bottom, S sub X, the sample standard deviation of X, is going to be 52.2287. Okay, and when you stick that into the calculator and you get an answer, it should come out as 0.11553098. Again, that's assuming that you didn't round anything prior to figuring this out. I'll switch back to blue. So that's B sub 1. So now we have to find B sub 0. So B sub 0 is going to be your Y with the bar. So we're going to have 6.98583333. 5.8 minus b sub 1, again, is what we just found up here. Okay, so I'm going to say that is, I left out a 0 there. Change back to my red. I'm missing a 0. Sorry, there's a 0 in front here. I do apologize. Okay, so that's going to be 0.1, that's why I did it again. 0.0116 times 126.25, and again, that's coming from x with the bar up at the top here. Okay, and again, when you chuck that into the calculator, you're going to get an answer of 5.52723. Okay, so that is going to be your b sub 0. So now we have b sub 1 and b sub 0. So now we're going to go back and we're actually going to answer the questions. Again, part A was to write the linear regression equation. Okay, so again, this should be y with a hat. So y with the hat equals b sub 1, which again is going to end up being the slope of the line. And pretty much any time that we're talking about anything with a decimal from here on out for the rest of the year, you're always going to round to 4 places. So again, you can see that from up here, what I'm circling in blue, that red number that I just circled in blue, when you round that to 4 places, that's how you get the 0.0116, tack on our x, and we'll do the same thing. We'll round this to 4 spots, which will give me the 5.5273. So there is the equation of your linear regression line. Okay, for part B, you wanted to predict the drilling time if the drilling starts at 130 feet. Again, 130 feet represented X. So what they're really asking you there is what happens if X is 130. Again, this is Y with a hat. Okay, so all I did was take that equation that we just found, and now I'm taking out the x and plugging in 130, and when you chuck that into the calculator, you should get 7.035. For part C, it wanted to know, is the observed drilling time at 130 feet above or below average? So for the observed time, literally all I'm doing is going back into the chart. Here's 130. That's where I'm getting that 6.93 from. So the observed drilling time is 6.93 seconds, and the predicted drilling time is what we just found right here, which is 7.035 seconds. So that means the drilling time of 6.93 is below average. Okay, and then the last thing that we want to do is draw the least squares regression line on the scatter diagram of the data. So again, all I did was plot those points. I used Excel, and again, I screen captured it. But there is my scatter plot. And again, to get the actual line, when you want to draw that, you can just put the equation, this equation, into y equals on the calculator, and then go into your table of values and pull off any 2 ordered pairs. Okay, so let's say it was approximately this one and this one. You just plot those points and connect those dots, and then you'll have the best estimation of that data. Okay, and one more time, I'm just going to go back into the calculator, and then that is going to be it for this video. When I go back into the calculator, hey, I still have my linear regression up here when I found my R value. And now look back at the value of A and B. Hey, again, A was your slope. Look at that. That's exactly what we just found by hand. B, your y-intercept, that's exactly what we just found by hand. So again, wanting to know where your calculator is getting that information from, now you could always find that value, your slope and your y-intercept of your linear regression by hand. You know what your calculator is doing. But again, you can always just go in and pull off your whole entire linear regression line right off the bat from your stat calculate and then option number 4. And that is it.